Okay, so welcome to our next lecture on machine learning fundamentals. Today we are going to cover a very interesting topic of so-called automated machine learning, AutoML solutions. Okay, so until now we have already used Dataiku as a data science platform, which helps us to automate different tasks like feature engineering, model choice, model training, model evaluation. But these systems are commercial, and on the other hand, they are still in most cases just a visual overlay over the open source libraries like scikit-learn or PyTorch or some other libraries. So today I would like to show you different open source solutions which can automate machine learning processes. And I hope it will also explain why I do not spend that much time on explaining you the technical details of different machine learning methods. Why? Because as you will see, it's almost fully automated nowadays, and in my personal opinion, it's much better to invest your energy into rather managing of the pipeline rather than mathematical details of machine learning solutions. So let me start with a brief introduction in the form of the PowerPoint, and later on I will show you the practical example of AutoML solution. So I hope you can see it well now. AutoML stands for Automated Machine Learning, and there are plenty of libraries at the moment at hand. The most popular, and this is the state for December 2022 when I made this quite thorough comparison of different platforms, are free: PyCaret, AutoGluon, and AutoKeras. Okay, today in my workshop I would like to show you how to do things in PyCaret, but I will start with some introduction of those three platforms, okay, just to compare them. So going straightly to the comparison, this is my own comparison, once again made on December 2022, so a few months ago, 6 months ago, so some things could have changed until now, is the following. Firstly, on the left-hand side, you can see different aspects of machine learning data science process which can be automated. So automated means that the computer will do the things for you automatically. As you can see, firstly, the first aspect of my comparison is what type of data you can analyze, you can model using those tools. And we have three types of data: tabular, text, and image. And tabular data, just tabular data, like we use most cases in our course. Text is just mostly natural language processing. The only thing I know that probably PyCaret has already resigned from this because there are much more better libraries like Spacy.io, where people specialize only in natural language processing. Moreover, the growing interest in large language models also made solutions like Hugging Faces exploding. So probably PyCaret has already resigned. It's just to be checked out of this. And the final thing is just an image. So as you can see, PyCaret probably works at the moment mostly for tabular data. Didn't support image recognition, but AutoGluon and AutoKeras can help you with this. Next problem: supervised and supervised learning and time series forecasting. As you can see, PyCaret helps you to solve all those problems. AutoGluon focuses mostly on supervised learning, like Keras. Next, you have pre-processing steps like explorative data analysis, data preparation, scale transform, feature engineering, feature selection. Everything is supported in AutoGluon and is not supported into other solutions. Next, you have train, optimize, analyze stages, and deploy and create app and monitor deployment. As you can see, PyCaret supports all those stages. And next you have libraries like scikit-learn, SGBoost, neural net. Interesting thing, PyCaret does not support neural nets, but AutoGluon and AutoKeras did it. So, and once again, the number of stars on GitHub, which is also important aspect of the library I personally use, is here. As you can see, they are have almost the same popularity among the community. So this is the general comparison. As I said, it could have changed since December 2022, but it looks like that. So now, I think it's a good time now to go to see these libraries as they are at the moment on the website before we proceed with a demo PyCaret. And let's see the docs website. And when you look at the modules now, as you can see, we have a supervised machine learning. So we have classification and regression problems supported by PyCaret, unsupervised machine learning, clustering, anomaly detection, and time series forecasting. So you do not have this natural language processing I already mentioned. Each of those are supported with a very interesting and good quick starts and tutorials. So if you would like to learn how to use AutoML, I definitely encourage you to test it because they have very powerful examples, very interesting examples, and with a very good explanation of the overall the philosophy which is behind. The only thing you need is just basic knowledge of Python, and you must be capable to install the PyCaret on your machine, which is, by the way, very well described here. One technical example, practical remark, it is really advised to precisely follow the installation guide presented here by PyCaret, and then my practical advice is that especially for PyCaret, it's very good to install it in a dedicated Conda virtual environment. Why? Because PyCaret uses its own combination of specific versions of Pandas and NumPy, for example, which are key libraries for machine learning, for data science. And if you install it in your base environment, if you do not have a habit to create a virtual environment for your project, it may happen that it will substitute your current version of Pandas, for example, or NumPy, with its own, and some other code you already created with the previous version of Pandas will not work. So once again, I strongly recommend you to install the PyCaret in its own virtual environment, following those suggestions. There is also another very interesting option. If you know a basics of Docker, if you can install the Docker on your own machine, whether it's Python or Mac or Windows, PyCaret has very good Docker images. You have two images, full and light. And if you just simply start the PyCaret Docker in your computer and then run, for example, this command in a command line, it will automatically start the Jupyter Notebook with a dedicated PyCaret kernel, so you do not need to install literally anything. Yes, so this is also another interesting way of giving the PyCaret a try. Any questions till now? Okay, so if not, a few words about the data processing stage. As you can see, you have data preparations like handling missing values automatically, discovering data types, one-hot encoding for categorical variables, ordinal encoding, cardinal encoding, target imbalance management, outliers detection removal. Next, we have all the dedicated skeleton transform libraries. We already mentioned this on our previous lecture. So we have dedicated libraries for normalization, feature transformation, target transformation. Next, we have a very, very interesting set of procedures for feature engineering, feature selection, and some other parameter setups. So this is PyCaret in a nutshell. If a few minutes from now, I will give you an example of the sample project realized in the PyCaret. What I did, I just simply adopted the PyCaret tutorial on classification to my own data set. So it's new in that sense, but I have chosen completely different problem, completely new data set. The same data set we already used on DataEco in our previous lectures on churn prediction. So you will find it also in my folder. In our folders we have this at the themes. But before we continue, I would like to show you two other libraries I already mentioned, namely AutoGluon, which is developed by Amazon. And to be quite truthful, it does not look that nice like PyCaret, but in my personal opinion is a better tool, especially for industrial solutions. So for example, in my commercial projects, I use AutoGluon. So for the learning, teaching purpose, I suggest PyCaret because it's very elegant and very well described, but for real implementations in business, I strongly suggest to also use AutoGluon. Why? Because it has very interesting, more advanced features, like for example, we can limit the time of training for example, if you have some computer power limitations, so you can say, okay, as a hyperparameter, train this model for 1 hour, not more. Moreover, it has some very advanced feature preparation options, like for example, once upon a time in one of my projects, I had to optimize the model for recall, and I needed a dedicated set of feature transformations functions, and I have found them in AutoGluon, and they were not present in PyCaret. So there are many quite advanced options which make this AutoGluon solution also very powerful in the industrial applications. So this is obviously they have also quick starts and tutorials for tabular data, but as you can see, this is also multimodal. So we have image prediction, object detection, so you can see the text prediction, so full NLP support, natural language support. So that makes this AutoGluon also very popular tool on the market. And finally, we have AutoKeras, which is a tool built on top of Keras library. So if you are familiar with TensorFlow, you know that Keras is the high-level library on top of the TensorFlow, which helps you to quite easily create your own neural network architectures. And AutoKeras is AutoML for Keras. So this is the solution of the so-called type neural architecture search. So it automates the search for the optimal neural network architecture. So for years, it was extremely expensive in terms of the computing power, because you know that the training of the neural network is expensive itself. So if you would like to optimize the architecture, you need to train a lot of different models, and it takes time and computing resources. But fortunately, in last years, different research teams have developed very smart solutions which make those processes simply affordable. And AutoKeras is one of the libraries which specialize in neural architecture search. So once again, if you would like to automatically identify the optimal architecture of your neural network, I suggest to try AutoKeras. Okay, so we won't spend time on this. Personally, I do not use neural networks in my commercial projects, but still, if you have something like this on the table and you do not, you need to identify some architectures, I think definitely you could try this. Okay, any questions? Okay, so if not, let's continue with our examples. So now I will proceed to the demo. So let me close the PowerPoint. In this PowerPoint I presented different screenshots from the system, so there is nothing more informative on this. And now I would like to focus on the demo of using PyCaret for classification problem. So I open the terminal in my computer. I need to activate the PyCaret environment. Once again, this is what I strongly suggest you just to have a habit. Create each time you initiate a new project, whether it's a training project or commercial project, or would like to learn some library, it's good to create a new virtual environment. I personally use Conda environment for this, for Conda for virtual environment management on my Mac. So I activate this PyCaret, and now I will start the Jupyter Notebook interface to work with my example. So the Jupyter Notebook is the visual interface, browser-based interface to interactive Python notebooks, not only Python, but in my case, this is the Python. And when I open the notebook, you have all the example described here. So what's the problem? The problem we are going to solve is similar to the problem we have already solved with the Taiko. We have some customers, the telecom company, and we have more than 10,000 data points. And for each customer, we know the state, area code, font, how many days this customer has spent, is it a customer, whether it has or not the international plan, which AutoML plan, which message, and how much time does this person speak. And finally, the variable we would like to predict is churn. Whether the customer left the company or not. 0 stands for no churn, 1 stands for it has left the competitor. So the goal of our modeling is to create a model which for a new customer will predict whether the customer will leave the company or not in case we do not contact this person. So this is the goal. Okay. So the first step, or maybe I'll just simply clear all the cells just to have it clean. So the first step, as usual, is importing the most important libraries. So import the pandas data frame. Next, I import the dataset. So this dataset is in the form of a comma-separated value file, which has data in the textual form, comma-separated values. As you can see, we have many different customers, which has some features, and then finally, the variable we would like to predict, which is churn. Okay, so this is our dataset, and if you have any questions in the during the presentation, please don't hesitate to interrupt me. Okay. Any questions till now, or it's clear?
It's clear.
Thank you very much. So next I can present. Are you familiar with Python, by the way?
Yes.
Very good. So you know the basics. So you know that we can see the head of the data frame. We can see its shape. So we can see that we have more than 3,000. Apologies, I thought that it was 10,000, but this is 3,333 rows and 23 features. So we have 22 features and one the variable we'd like to predict. So the next step is we will split the data set with the proportion 80-20, and we will train our model on this 80% of the data set, and this will keep for prediction in the future. Okay, so if we print the shapes, now we can see that we have 2,666 data points for training and 667 data points entries records about the customers for future prediction. Okay, just unseen data during the training. So we have the data. We didn't do anything with this, and now we approach the first very important stage in our analysis, which is exploratory data analysis. Exploratory means that we do not change anything. We just look at the data. Okay. So the first tool, which is also a part of AutoML, I would like to show you is pandas profiling. It's not PyCaret, it's pandas profiling. So for example, you can do pandas profiling in the internet. It's the open source library which you can install on your computer free of charge, which helps you to perform very advanced data analysis. You just simply click pip install pandas profiling and it will do the job. You will have it installed. So what it does. So as you can see, I simply call this pandas profiling, never mind the warnings, they are not key. And now look, if I click profile to know that will print out, first it will compute the basic statistics of this data set. Can you see data set? So that's gonna be a whole statistics of all those 3,333 rows. So now let's compute. It will take a time because it's very power consuming. By the way, this is the only disadvantage of pandas profiling. It computes so many statistics that even with only 3,000 rows and 22 features, it will take not that bad computer, which is my MacBook Pro. As you will see, a minute or so of computation. So if I have, let's say, 10 million of rows, it's almost unmanageable. But let's wait. Let's wait. You will see the result. Okay, and here we have the final report. And what do we have here? Firstly, we have the first snapshot, that information that we have 23 variables, 3,333 observations, no missing data. So this is very interesting. So it does automatically computes the missing data. I have a very clean data set. I did this preparation previously. And then I see that I have 4 categorical variables, 17 numerical, and 2 Boolean. Okay, so it also identifies the variable type. Next, for each variable, I have a description. Look, Firstly, it identifies whether the variable is categorical or numerical. Okay. For categorical variables, I have the following information: number of distinct values in percent, distinct in percent, missing values, some histogram, and then I can click more details. Can you see for a given variable? Yes, I have much more details on this: maximum length, median length, mean length, character Unicode. This is categorical variables. Then I have categories, as you can see. I have the frequency plot. I have number of words, number of characters. Yes, we have a lot of different variables. Next, for a numerical variable like account length, I have statistics. So it shows me that I have 212 distinct variables in percentage, number of missing variables, minimum value, maximum value, zeros. Yes, and then once again I have more details. And now I have all the statistics, like quantile statistics. I have a minimum 5th percentile, 1st quartile, median, 3rd quartile, 95th percentile, maximum range, interquartile range is automatically computed, as you can see. Next, I have a standard descriptive statistics, like standard deviation, coefficient of variation, kurtosis, mean, skewness, sum, variance, monotonicity. Next, I have a histogram, as you can see. It's very nice histogram of obviously beans. For 50, it automatically identifies beans, common values, and extreme values. And so, as you can see, it's a very powerful tool. And just to give you a comparison to Dataiku, if I log in here to our Dataiku platform, I have this project uploaded here, and this is the same data set. As you will see, this is a data set uploaded to Dataiku, the same data set, yes? And I can achieve the same goal using here this analyze button, which gives me also the same statistics. As you can see, for numerical variables, I have very similar. And I can scan some other statistics for other values, yes? So Dataiku also gives you something like that. The advantage of Dataiku is also this very powerful statistics tab, where you can create your own ad hoc statistical analysis using so-called worksheets, but that's another story. I don't want to go into details because we're at the moment on the lecture on AutoML solutions. The thing I wanted to show you that is that you have a very similar tool, which is open source. It's named Pandas Profiling. It generates you all the statistics, but also gives you some very interesting warnings, like, for example, phone is a categorical variable with a very high cardinality. Cardinality means that there are a lot of different distinct variables. It's obvious here. If it's a phone number, it's an identifier of the person, yes? So it may be treated as a key of the person, so it's natural that it's high cardinality, but in that sense, there's completely no sense to use this as a feature in your training data sets for the modeling, yes, because it has completely no value, yes. So for sure, if it's that high cardinal, it won't provide you with any information about the pattern on the feature, yeah, pattern, yes, which may impact, for example, the fact that someone is churning or not. So as you can see, you have all the statistics computed here, but later on, you have some other sections. As you can see, you have interactions. So you can, for example, click here, account length versus total time spent. Yes, you have the very interesting plot. Or international calls versus night charge. So you can play with those statistics and see how do they interact visually. Yes, so you have a lot of different plots at hand. Next, you have a correlations computed. So by the way, that's the reason why it takes that time to generate such a report. You have autocorrelation, but you can also add some show correlation descriptions with all the definitions. You have Spearman correlation, Pearson's, Kendall-Stowe, Kramer's, Phi. So you have many different correlations. Next, you have missing values count and the matrix, and that's at the moment trivial because this dataset is already cleaned and has completely no missing values. But still, if you would like to analyze a dataset looking for missing values, this is a very useful tool. And you have a sample which corresponds to the head or tail. First rows is a head, pandas, last rows is tail. So you can also see a sample of the data point. So this is the example of AutoML package, but in the area of exploratory data analysis. And before we continue, maybe you have some questions, comments. Okay, if you do not have, let me continue. So now we are approaching the most important stage. All the things I'm explaining you now in words are also described here in the text. So in case you would like to come back for this tutorial later on, you have everything described in the text. As I mentioned, it is a tutorial from PyCaret adopted to my case study, which is the churn prediction. So I have just simply changed the data set, the type of the problem, and then thanks to this, I was able to compare this to, for example, a Dataiku, which is the commercial data science platform. So first remark, PyCaret is AutoML, but up to some point. So as you can see now, the first command here I have is take classification objects from the PyCaret library. So that means I need to decide by myself that this is the classification problem and not a regression or segmentation problem. Okay, so this is the probably only not automatic thing you need to do. You need to decide that this is the classification problem. So now I open this, and in the second line, this is the most important line probably, you create the object of the setup class. Okay, this is a dedicated class in the PyCaret with the following information. As data points, take data frame. So data frame is something we have already created. This is the subset of our original data set with 2666 rows. Okay, so this is this. Next, specify the variable you would like to predict. And we would like to predict the churn variable. Look, it's here. We want to predict this variable. Yes, not this one, not this one, not this one, but this, the final one. We need to tell precisely the system what we want to predict. It needs to be done. Next, the train size is the information. Okay, PyCaret, take this 2666 rows and then divide this in the proportion 0.8 to 0.2, 80/20 to the training data set and the test data set. Okay, so this is for future model evaluation. That's going to train a lot of different models. Next, very important command, imputation type. So in case you find some missing data, at the moment we do not have any missing data, but we could have, yes, just input those data using the iterative method. It's described in the tutorial in the documentation of PyCaret. As you probably remember, we had many different ways of inputting the missing data. Like, for example, for regression, we may take a median, yes, or for classification, the most common value. Yes, there are many different approaches. So you say, okay, we suggest the PyCaret what type of the imputation strategy to use in case it finds some missing data. But also, as I said, we do not have this missing data here. Yep. Next, we specify, okay, what type of features we want to ignore, and we have already found that there is a very highly cardinal variable called found. So this is just a phone number. We are pretty sure that it will not add any value at all to our analysis, so we just simply ignore this feature. And some session ID, just a random number generator seed, random number seed, which, if specified, will help us to get the same results in the future session, if you would like to do something like this. Any questions? Or it's clear?
It's clear.
Okay, thank you very much. I'm just simply asking you because if I speak all the time, it may be very difficult for you to stop me. So let's do it. I just simply run the cell. It runs at the moment on my computer, and as you can see, it gives me the final result. Okay, it has prepared all the data for the analysis. This is the summary. And before we continue, let's check how it's gonna work in the case of data equal. Look, we have to do the same. I go to lab, the same problem. Yes, I click AutoML prediction. Yes, AutoML prediction. Once again, I need to check. I specify the variable to predict the same like in PyCaret. The only difference until now is that it will automatically identify whether it's a regression problem or a classification problem. So it can see that this is a value which has only two variables, so it's treated as a binary classification. Yes, binary classification. Obviously, I can go to design stage. I can go to features handling, and let's have a look. Yes, it has automatically rejected the phone because Dataiku has recognized that it is very highly cardinal. So this is the next advantage of the Dataiku above compared to the PyCaret. PyCaret, firstly, we had to decide whether it's a classification or not. It's done automatically in Dataiku. And secondly, we need to manually specify the phone as a variable we don't want to use in our case. Dataiku did it automatically, yes, but still, this is the same. And next, look, when we have this train test set, Dataiku automatically use this 0.8 train ratio. Yes, train ratio. In PyCaret, to the best of my knowledge, also this 0.8 is a standard value, so probably we do not need to specify this, but still I just simply kept this in my command line. So the goal of this setup is to prepare the system for future training. Yes, so it ingested the data and ingested all the hyperparameters of the training. So now we are ready to train the model. Okay, we are ready to train the model. So all the training is here. This line does all the job. Best model, so we call a method best model. No, we create a new object, best model, as a result of compare models function. Let's click it. It will be much better to see. If I run this code, as you can see, it trains under the hood many different machine learning algorithms. It shows me accuracy, area under the curve, recall, precision, F1, kappa, MCC, and TT parameters. It performs tenfold cross-validation under the hood. And finally, gives me the results. And as a top model, it gives me the model which has the highest area under the curve. But if I would like to optimize for recall, I can simply run this once again. And now the best model would be this one, optimized for recall. You probably remember that the recall is used in case we do not want to miss when we want to minimize so-called false negatives. False negative means that we say that someone has a negative value, it won't churn, but in fact it churned. Yes, so recall is just for this. So as you can see at the very top, we have at the moment this library XGBoost, which is probably the best model. So it's all the training. And in fact, when we do the same job here, look, we have the design stage. When I click train, let's make a training just to compare the results. As you can see, the random forest here gave me the 0.91 result. And here I have 0.9022. So as you can see, for the first shot, PyCaret is better. One important remark. This PyCaret is trained on the lower number of records. It's 2,666 records compared to this one. So it probably should give us a bit worse details because it has a lower number of records, but still it's better than the Taiko area under the curve. So as you can see, it's very, very interesting. And this Taiko is a very, very good library, obviously. In the design stage, we can now, let's have a look. Here, the XGBoost is the best model. So now we can go to algorithms. We can turn off those, choose XGBoost, and let's try it once again, just to compare whether the XGBoost implementation of the Taiko will give us a better results compared to PyCaret. Let's have a look. It's good to make such experiments sometimes. Nope, it's not better. So as you can see, it's very interesting that the first shot from PyCaret gave us that good implementation. Okay, so now let's continue. Now we can print this best model. This is a very interesting feature. What does it mean? That gives us all the hyperparameter values, not all of them, but we can make it, print it out with all the values. As you can see, XGBoost classifier has a lot of different variables, hyperparameters, and those hyperparameters are very important for future implementations. So, for example, if you would like to put this model into production, the next time you do not need to train all the models from scratch on your dataset, but you can use precisely this model, assuming that this is the best model to choose and train it only this model instead of training a lot of different models. That would be important in case you have thousands of models with a lot of data and you would like to save your computer power. Sometimes I do that job in the lab. I identify the best model, and then later on I take those hyperparameters, and in the future, in the production stage, I just simply retrain the models on the new incoming data, let's say on a weekly basis, but using only this model with the hyperparameters taken from the lab session I did here, as you can see. So, okay, the next step. Okay, we know which model is the best one, but now in that stage we can fine-tune this even more. So first thing I do is I list all the models available at the moment in PyCaret. So here, as you can see, the XGBoost is here. So let's train it. I will just simply take this XGBoost, XGB, create the model XGBoost. So that's gonna fine tune this model. I need to copy precisely this one. So now I create the model from scratch. It gives me, once again, as you can see, it makes so-called tenfold cross-validation. We're talking about the cross-validation previously. Just to remind you, this procedure is just to secure us from the situation in which the random split of our dataset into train and test may impact our results on the test data. Yes, so in order to minimize this risk, we just simply perform 10 times, we make the training on different subsets, and then we average the result, and as you can see, we get this very, very high, nice value of area under the curve, 0.9226. And having this model, now we can approach for its in-depth analysis. And look what's going to happen now. Oops. Okay, XGBoost. It performs a lot of different statistics. And now it deploys this on the internal website in the following form. Obviously, I can deploy this on any web server, and as you can see, I have a lot of different informations. Firstly, I have the feature importance. So as you can see, total chart is the most important. International learning plans, customer saving calls. So I have this feature importances. I can compute them the associable values, which is probably the better version here. Next, I have the classification statistics. Yes, for a given cutoff, I can compute, for example, confusion matrix. Yes, I can compute all those statistics like accuracy, precision, recall. Can you see it has a very nice tooltip showing me the definition of this. Yes, F1, ROC, area under the curve score, etc. Next, I have the precision plot, classification plot. Yes, different subplots, cumulative precision, a lot of different options here. Next, I have a dedicated dashboard for individual predictions. So this is for explanatory analysis. So this is so-called XI, self-explainable AI. Next, I have the what-if analysis. Can you see? So I can play with different values of those of my systems. So for example, I can select the index. Yes, I can compute the value of a probability prediction of the given variable. So all those simulations are available here in this what if analysis. Then I have a feature dependence and the decision tree in case we have a random forest, but it's not decision, so we do not generate this. So as you can see, this is the very rich dashboard generated by open source solution, and it corresponds to the following dashboard. If we click this button here on Dataiku, we have also what if analysis. It's a bit nicer format, yes. So I can simply, as you can see, play with different values. I can do the same in the model explainer here, but it's a bit less intuitive than in Dataiku, but still the functionality is the same. Next, I have variable importance, as you can see, the same results, partial dependence, subpopulation analysis, individual explanations. These are the part, the explainability tab, which is visible here, individual predictions, yes. Next, I have a confusion matrix, decision chart. A leaf chart probably is not available, but we'll have to check it out in the model explainer. So as you can see, Dataiku has its own dashboard to analyze the predictive power of the model. In that case, this is the GBoost, like in our case. PyCaret has its own. PyCaret has its own dashboard, also very interesting. Any questions? You can also, as you can see, download such a tab. I can download, let's say, feature importance in the form of HTML in order to save it. Yep. So as you can see, open source solution, but extremely powerful, since this process is running in the background because it serves the model explainer. I need to kill it before we proceed to the next step. Okay, so that was the training of a specific model. Now we can create a fine-tuned, even more fine-tuned model, XGBoost. Yes, this is the object we created, and now I can optimize for example, recall. Yes, so let's train it. We need to wait a second. So now it's gonna make a very thorough hyperparameter scan in order to maximize the recall. In our case, let's have a look. The recall of the previous version, as you can see, was 0.84. Now, after the optimization, is 0.98. It's really powerful step. It's close to 1. So as you can see, we have a very nice tuned XGBoost model. Yes. So we can now we are ready to deploy. There are some options here. As you can see, I can generate the dedicated plots here, like, for example, confusion matrix to the model, yes, or area under the curve plot. Why do we use this? You may ask, okay, but we have this very nice portal here running, so why do we need this? That may be very useful, and it's just a snapshot of what we are going to talk about on This architectures are artificial intelligence systems in the next semester. If you want to join me in this lecture, sometimes we need to store all the results of our experiments on the external database, and for this purpose we may use either commercial solutions like weights and biases, which is here. Yes, this is what I in most cases use in my research projects. In weights and biases it works that way, and that I embed a small Python snippet within my training code, Python code, and it later then, after each run, sends the key statistics I need about my run, like for example, number of records, the results like accuracy, recall, F1, and for example, plots, as you saw now, because I can send also graphics and send it to my account on weights and biases somewhere in the cloud. And the nice thing about is that thanks to this, I'll show you the real example, is I can run different trainings. Like for example, here is another project I work on the moment, on reinforcement learning. So I just simply run this code. Oops, I need to log in because it requires the login. So now it's gonna spin up the TensorBoard. So my procedure is the following. I start a run on an external machine that may be a server somewhere in the cloud. This run takes around 3 days to complete. So instead of sitting by my machine, I'm just simply sending these results live into the cloud. And here, as you can see, I have a dedicated website which I can visit whenever I want, because I added this hyperlink to my favorites, yes? So I just simply visit this hyperlink and I can see the progress of training, okay? I can see how the error of computation is getting smaller and smaller, and I can also share this with my friends. So for this purpose, sometimes I need to send also some images, and for example, in our case, that may be this image. Yes, so that's why sometimes I need to have a way of to generate a single plot, because that will make it possible to send it somewhere to the cloud. So this is weights and biases. Unfortunately, it's in the cloud, so I cannot use it in commercial projects. Why? Because I would send the sensitive information to the external cloud provider, which is not allowed for commercial projects in all cases, where you need to keep the sensitive data on your own servers, on-premise solutions. So for that purpose, you can use, for example, MLflow, which is the open source solution provided by Databricks, one of the most popular machine learning platforms. And they have MLflow tracking, which is a dedicated solution for tracking experiments. And now I can install it on my server. I can do precisely almost the same things as I did with weights and biases. And yep. And then once again, it will be useful for you to be able to store those results as plots, because then you can send this graphics precisely to your system as a local database. Okay? Any questions, or it's clear?
It's clear.
Okay, thank you. So the next step is to, I have also some older function XGB. here. No, but that's the older function. Okay. So the next step is to predict the model on the holdout sample. So, oops. Apologies for this. I don't know what happened. Sometimes happens. Okay, never mind. So the final step, I hope it will work now. Let me check. Yep, fortunately. This is a very smart procedure now. Look what happened. Previously, when we had, let's come back because it's very important from the perspective of the whole the training process, data science process, which we encounter in the industry problems, in the real life problems. Look, we have the original data set. Yes, this data set has 3,333 rows. Next, we have used only 2,666 of those rows on our training here. Yes, can you see? But so this model was trained on those 2,666 rows, but in fact, it was trained on 80% of those rows and evaluated on 20%. Why? Because if you would like to have any way of comparing these models between them to identify that the XGBoost is the best, we need to evaluate XGBoost. So in fact, we have trained the model on 80% of those 2,666 rows. Yes. So, but now knowing that this tuned GBC is the best model we have already found, we make now here, this is this one, this is this line. We click final DT. What we do now is we retrain this model, but now on the whole data set, on this 2,666 rows we have in that. Okay, so now we forget about splitting this into 80-20. Why? Because thanks to this, we will have a better prediction at the end of the day. Yes, so now we have this final model. Yes, this is the final model. And now, yeah, so it's not final XGB, final XGB. Let me check this. Apologies for the, because I always change the models in my demos, so not okay, some mistake, never mind. Okay, so this is the finalized model. So once again, this model has been trained. This is the best model we got after fine-tuning. All the hyperparameters are fine-tuned. So we have this model as final XGB, and now we can use this model to predict unseen data. What's that? Once again, coming back to our first step, look, we have separated 667 rows, yes, from our data set as unseen data, and now we can use this data set to predict unseen data, and this is this line. So we say, okay, these are unseen predictions, yes, so let's use the function predict model. Let's take this best model we have trained, yes, and as data use unseen data and show us predictions. I don't know what's going on here. There is an error here, lens mismatch. Know what's going on here, but never mind. That's very strange. Okay, and finally, we can save this model on our drive. So our final XGBoost model. Now we have, what's the month today? It's June 2023, and I can save it here. And as you see, it's already in the serialized format, PKL format on my drive, saved today. So this is the model I already saved. And this is the final step of my work as a data scientist. I take this model, I save it on a drive. As you can see, it's only 159 kilobytes size. And I give this to my customer and say, okay, now you can build the app around this. Yes. And building the application around this is the subject of the next course on SUML. Yes. So środowiskowo chominowe uczenia maszynowego in Polish. And later on also the subject of architecture of artificial intelligence. So the next lectures in the specialization will start with such a file. We'll take it as given from the data by the data scientist. And next, what is done later on? I just simply load the model. I need to take the same number, the same not number, but the name as here. Okay, so now this is what's going on in the production stage. Okay, so we load the model, and then I can read the customer's chain as unknowns, and I can generate predictions. Hopefully it won't generate the error. Yep, it's perfect. Yes, and we can see the new productions head. Okay, so as you saw, we can now read the saved model and apply this model the unseen data. Yes, so that's what's going on the production. As you can see, it gives us the prediction label and prediction score to the data set. And finally, I can create the app using this. This is the funny tool because it's just for, I would rather call it a toy tool. But if you want to create the app, look, I just simply run this. I create the app here. Yep, and now I can have it running. As you can see, I can ask the system to predict a churn for someone with some data. As you can see, I can input some data points. So that's gonna be the same procedure as in the production. So I just simply call it, and oops, I got some error. I don't know why. I don't know. Apologies for this. That's strange. It should give me some result, but as you notice, I had some problems. Maybe because, no, I don't know why. Never mind. It should work. It should generate the app with the proper, but maybe that's a question of the update of the application. But still, I think that we did the most important part. So just to sum up, PyCaret gives you the ability to load the data. It requires you to choose the type of the problem that may be supervised learning or unsupervised. For supervised, that may be classification or prediction. Supervised, that may be, for example, segmentation using k-means method, etc. Next, it does almost all the job under the hood. It performs the feature transformation, manages missing values. It trains a lot of models for you. It enables you to fine-tune the model and finally to train it on the whole data set and save it in the serialized format like Pico. And having that, you can load it and later on deploy the app around this in the production. So what I can suggest you for the future, if you would like to learn, I definitely suggest you to give a try to segmentation methods, because they are very, very important for the business cases. So go for tutorials, models, apologies for this, go to unsupervised, and for example, try clustering quick start or tutorial. It will take you 15 minutes and you will go through the most important steps. You can also try to beat Dataiku, try to compare the efficiency of Dataiku, which is a very powerful commercial platform. And as you saw, the first shot shows that PyCaret is even better. The final thing I can suggest you, if you want to spend an extra hour to play with AutoGluon. So take the same data set, the same problem, and try to use AutoGluon. Look, this is the essentials here. This is the quick start guide. It shows you how to train the AutoGluon. We used AutoGluon AutoML solution to predict, for example, the customer churn. Yes, so this is how I personally learn. I just simply use such a getting started guides, and I substitute them with my own problem, my data set, and then later on I know how the system works in reality.